Good day, everyone. We are here to discuss a topic about techniques on uncertainty reasoning. Though there are various types of uncertainty in various aspects of a reasoning system, the reasoning with uncertainty or reasoning under uncertainty. Research in AI has been focused on the uncertainty of truth value. That is, to allow and process truth value other than true and false. Generally speaking, to develop a system that reasons with uncertainty means to provide the following. First, a semantic explanation about the origin and nature of the uncertainty. Second, a way to represent uncertainty in a formal language. Third, a set of inference rules that derive uncertain, though well-justified conclusions. Fourth, an efficient memory control mechanism for uncertainty management. The first technique is non-monotonic logics. A reasoning system is monotonic if the truthfulness of a conclusion does not change when new information is added to the system. The set of theorem can only monotonically grow when new axioms are added. In contrast, in a system doing non-monotonic reasoning, the set of conclusions may either grow or shrink when new information is obtained. Non-monotonic logics are used to formalize plausible reasoning, such as the following inference step. So here are the example. Birds typically fly. Tweety is a bird. Tweety presumably flies. Such reasoning is characteristic of common sense reasoning where default rules are applied when case-specific information is not available. All systems of non-monotonic reasoning are concerned with the issue of consistency. Inconsistency is resolved by removing the relevant conclusions derived previously by default rules. Simply speaking, the truth value of propositions in a non-monotonic logic can be classified into the following types. First, facts that are definitely true, such as Tweety is a bird. Second, default rules that are normally true, such as birds fly. Third, tentative conclusions that are presumably true, such as Tweety flies. When an inconsistency is recognized, only the truth value of the last type is changed. A related issue is belief revision. Revising a knowledge base often follows the principle of minimal change. One conserves as much information as possible. One approach towards this problem is truth maintenance system, in which a justification for each proposition is stored, so that when some propositions are rejected, some others may need to be removed too. Here are the major problems in these approaches. Conflicts and defaults, such as in the Nixon diagram. Computational expense. To maintain the consistency in a huge knowledge base is hard, if not impossible.
The second is probabilistic reasoning. Basic idea. To use probability theory to represent and process uncertainty in probabilistic reasoning, the truth value of a proposition is extended from 0,1 to 0,1, with binary logic as its special case. Justification. though no conclusion is absolutely true. The one with the highest probability is preferred. Under certain assumptions, probability theory gives the optimum solution. To extend the basic Boolean connectives to probability functions, negation, probability is not in A is equal to 1 minus probability of A. Conjunction, probability A and B is equal to P of probability of A times probability of B if A and B are independent of each other. Disjunction, probability A or B is equal to probability A plus probability of B if A and B never happen at the same time. Furthermore, the conditional probability of B given E is probability B given of A is equal probability B and A divide probability of A, from which Bayes' theorem is derived, and it is the often used to update a system's belief according to new information. Probability H given by A is equal to probability G given H times probability of H divide probability of A. Bayesian networks are directed acyclic graphs in which the nodes represent variables of interest and links represent informational or causal dependencies among the variables. The strength of dependency is represented by conditional probabilities compared to other approaches of probabilistic reasoning. Bayesian network is more efficient though its actual computational cost is still high or complicated problems. Challenges to probabilistic approaches: unknown probability values, inconsistent probability assignments, computational expense. Considering the uncertainty in probability judgments, some peoples go further to study imprecise probability. So, in probabilistic reasoning, so bali, kani siya nga technique katong way nga about datong akong gipang discuss sa una, balik kani siya kay ang pasabot mag-usab probabilistic reasoning, wa ta kahibaw bisag unsa kung unsa atong mahimo nga decision, wa ta kahibaw kung unsa gadyoy exact nga solution sa atong mga desisyon. Third of techniques is Fasciology. Fasciology is a generalization of classical logic and reflects the impression of human language and reasoning. Example of fuzzy concepts: yeah, for nature, most, cloudy, and so on. According to fuzzy logic, whether an instance belongs to a concept is usually not a matter of yes or no, but a matter of degree. Fuzzy logic uses a degree of membership, which is a real number in 0, 1. A major difference between this number and probability is the uncertainty in fuzzy concepts usually does not get reduced with the coming of new information. Compare the following two cases. 1. I'm afraid that tomorrow will be cloudy, so let's take the picture today. In two cases is I'm not sure whether the current weather should be classified as cloudy or not. So, this is the example of basic fuzzy operators. Negation. Aim is not A is equal to 1 minus aim A. conjunction. Aim A and B is equal to minimum M and A and aim and B. Disjunction. Aim A or B is equal to max M, A and M and B. Typically, in building a fuzzy system, the designer needs to provide all membership functions included in it. By considering how the concepts are used by average people, most successful applications of fuzzy logic so far are in fuzzy control systems, where expect knowledge is coded into fuzzy rules. Challenges to fuzzy approaches. One is degree of membership is often context dependent. Two is general purpose. Fuzzy rules are hard to get. So bali, fuzzy logic big sabihan gud ani ni is malabo. So bali katong mga techniques nga mga example nga nang na-mention sa una, kuan siya murag kanang kuan siya malabo. Mag-example ra man kog lain nga kuan panghitabo halimbawa kanang maghagbong ta og piso. Gihagbong nato wa ta kahibaw og unsay mahitabo na makuban na siya or mahayang. So bali kaning mga techniques nga fuzzy wa ta kabaw malabo ni siya nga makatabang or makadevelop sa AI.
The last techniques, we have truth value as evidential support. In the modern era, abundant information is easily accessible from various sources. However, only a few of these sources are reliable as they mostly contain unverified contents. The basic idea is to see the truth value of a statement as measuring the evidential support the statement gets from the system's experience. Such a truth value consists of two factors: frequency, the proportion of positive evidence among available evidence, and confidence, the proportion of currently available evidence among all evidence at a near future. This approach attempts to uniformly represent various types of uncertainty. And that's all. Thank you.